Now we have seen that when charges move, is called as current. The cause of it is voltage, and making use of the energy is your resistance, right? And we also learned about the resistivity or resistance of a wire given by R is equal to rho L by A. Now we're going to learn how to connect electrical components. So we have series and the other one is parallel, and the combination is also possible. So what is series connection? In terms of its property, the number of nodes that they share is 1. In terms of charge, same bunch of charge passes through them. In terms of voltage, it need not be same. This you'll understand once you do numericals. Okay. If you want to exactly understand all of this, let's move on to this resistive path, right? So we have this resistive path. In this, the path 3 is your series connection, not parallel, series connection. So this is your first resistor and this is your second resistor. So here you can see that there is one single node that is shared by both. So what is a node? Well, node is a point wherein the terminals of the electrical components are meeting. Right? Makes sense. So if I leave a ball bearing over here, it will by default pass through R1 and R2. So they have the same charges going through them. So in terms of voltage, okay, we'll discuss about this again later. So I have an example over here, a practical example, a physical example. So wherein the components are connected in series. So we have the terminal from the resistor connected to the terminal from the LED. So they have one single node. And yeah, in time we'll see that the current going through the resistor, the same current will go through the LED. And again, symbolic representation of this connection. So you can see the terminals being connected at this node. We call this as node 1, node A. This is that node, right? This is your series connection. So the key thing is here, they share one node and the same current goes through that, goes through both, basically. If you need to remember this because parallel connection is a lot more confusing than this. This is the easy part. And recognizing which is in series and which is in parallel is part of your syllabus. The next one is your parallel connection. So in terms of property, node, they have two nodes in common. In terms of charges, the bunch of charges going through one will not go through the other. In terms of voltage, they have the same voltage. So the first, second, and the third, all of these three you can remember to classify a connection as parallel connection. So let's jump on to trying to recall from resistive path. So remember this cutout. So when we left ball bearings, one of it took one path and other bunch of it took the other path. Is it not? Right? So this is your parallel connection. Whatever went through one did not go through the other. And you can clearly see they share two nodes, that is two connections. So at the top one and at the bottom another. So this is your node 1 and this is your second node. The voltage remains same. That again we will understand once you do the numericals. Right? So physically, I have an example over here. We have two resistance. And again, hope you guys remember and understand the working of a breadboard. So by default, this end and this end is connected. Right? Of course, this is not a complete circuit. This is just a small part of it actually. So symbolically, you can represent this connection as, see, this is your first node, node A, and that's your node B. Right? So this we can term it as node A, and that's your node B. Okay. And yeah, you can call this as R1, this is R2. This is R1 and this is R2. Again, you need to understand every aspect of this. That there is two nodes that is common in parallel connection. As you can see, two nodes are being shared by both the resistors. That is basically indirectly they're telling two terminals are being connected. In terms of charges, same bunch, different bunch of charges run through them like this over here. In terms of voltage is something that we'll understand with the help of numericals. Okay. So to recap, series connection, one node, parallel connection, two node. Charges, same bunch of charges. In parallel, it is altogether different bunch of charges. Voltage, we won't talk about voltage till we do numericals. So pause and you can make a note of all of this.